In this lecture, we are going to get introduced to a very fine technology, the sensor cloud technology, which has become popular in the last few years. It is popular particularly for IoT environments, for the development of IoT environments. So, sensor cloud. Sensor cloud, as the name suggests, is about integration of two technologies, sensor networks and cloud technology. So, the whole idea is through the integration of sensor technology or sensor network technology with cloud, can we offer sensors or sensing as a service in the same way as in the traditional cloud computing platform, which we have gone through in other lecture. So, in cloud computing, people are talking about offering computing facilities as a service, infrastructure, computing infrastructure as a service, software as a service, platform as a service, and so on. So, this is what we have gone through in the during the cloud computing lecture. So, here in sensor cloud, we are talking about, can we have a model where sensors or sensed data or sensing can be offered to end users as a service. A very fine technology, a very nice idea that can basically revolutionize the way we look at IoT today. So, let us look at it further. So, in sensor networks, we are primarily concerned about sensing of a particular region where the sensors are deployed. In cloud computing, we are primarily talking about storage of the data, processing of the data, and so on. However, when we talk about sensors and cloud together, we are talking about how we can basically integrate the benefits that are obtained from each of these two technologies, but those benefits are not merely about getting the sense data to the cloud, dumping the sense data to the cloud, or it is not about the simple virtualization of the sensors, the way we have seen that computing platforms are virtualized in cloud. So, here also it is not a very simple integration of sensors and cloud computing technologies. So, it is not a mere integration of sensors and cloud computing technology, and also at the same time, so it is neither the integration and at the same time it is nor the dumping of the sense data to the cloud, neither of these two. So, we can think of it as both of these plus some additional attributes, neither of these alone, both of these together plus several other benefits that we can get out of this integration. So, just a quick recap of sensor networks, we have already gone through it in detail. So, in a sensor network, what we have? We have these sensor nodes sensing the physical phenomena that are occurring in the environment of their operation. These nodes send the data, the sense data to the sink, which is a centralized unit, and the communication between the sink and the other sensor nodes in the network is typically multi-hop, which can also be single hop if the sensor node, that means the source node and the sink, are sufficiently close to each other. And the sink node basically either processes the data itself further or it sends it to a server for further processing. So, this is what traditional sensor networks does. So, in a traditional sensor network, we are typically talking about such a scenario. We have these sensor nodes connected to the sink, sensor node sensing the data, sending the data to the sink, the sense data to the sink. So, we have in every sensor node a sensing unit, a processing unit, and a communication unit. Sensing unit will have to sense what is going on around it, processing unit will do some processing some basic processing, and the communication unit will send it forward to the next hop neighbor for final delivery to the sink. The different applications of it, sensor networks, we have already gone through again. Target tracking, wildlife monitoring, healthcare, industrial applications, smart home, smart city, agriculture, vehicular networks, that means connected vehicles, and so many different types of applications of sensor networks. Cloud, let us have a brief recap. Cloud basically provides an architecture, some computational platform which can be used on demand to get access to computational resources whenever required, that means on demand on a pay per use basis. So, the advantages of cloud technology over the traditional server based technologies like server farms, etc. One is elasticity, that means we can very easily scale up or down as per the requirement. So, if there is increase in the requirement of computational resources, then it without actually going about buying those additional resources, one can simply subscribe and pay for those resources and start using them right through the click of a mouse button. Self service, the resources can be accessed by self, that means the resources can be accessed by themselves, and themselves means the sensor nodes or the computational nodes. And so, we are talking about three types of typically or traditionally three types of cloud computing services: infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. And different cloud clients like different apps, web browsers, terminals, etc. are going to get access to the data and the services from the cloud. So, what are these services? SaaS, PaaS, and IaaS. And I will just give you some example once again. We have already gone through it, and I will skip it. I will not skip it, but I will go through it pretty fast. So, software as a service, a good example is Microsoft Office 365. Platform as a service, example Windows Azure. Infrastructure as a service, several examples of inclusion of storage spaces, computational resources, and so on. Now, let us come to the concept of virtualization, which is key to cloud and sensor cloud. So, virtualization, through the virtualization concept, physically one computer might be holding on to the resources, and to many computers those resources can be shared. They can use, those other computers can use those resources, can get access to the resources as and when required. So, overall the throughput and costs are going to be increased, and the benefit is that virtualization basically permits or enables the sharing of the resources, which means that the same resource can be shared by in turn through the reduction of the cost. Encapsulation, which is that virtualization technology basically provides a one-stop solution, a complete solution, giving a complete computing environment. Independence basically means that it runs independent, that means virtual terminal runs independent of the underlying hardware, and these virtual terminals are portable. That means that a user might be using the computational resources through a virtual terminal, and that resource, when it is not used, those resources map to the actual physical resources. Those physical resources can be made available to another user. The limitations of presented wireless sensor networks. So, what we are talking about is the overall price of procurement is quite high. So, if we have some sensing needs, so the only way to go about fulfilling those needs is to buy from the market sensors, sensor nodes, and sensor networks, and then go about deploying. Then the question is that we also have to be careful about which vendor we want to procure from, and the types of sensors that are integrated to the platform. So, this is one limitation. Second limitation is about deployment. So, what is required is to have the right way of deployment and the right place of deployment. Right way means the how it is going to be deployed and where it is going to be deployed. And in terms of maintenance, post deployment maintenance and battery lifetime are other limitations of sensor networks. So, from an application perspective, again what we see is when the application changes, the requirements also change. However, as we will see that the sensor cloud technology can come to a rescue at least partially. Through the introduction of sensor cloud, not only the mere integration of, so sensor cloud is not only the mere integration of cloud computing and sensor networks, but it is also about pay per use facility, offering pay per use facility, using the concepts of virtualization of the sensor node, and introducing a layer between the sensor node and the end user. So, here is a side by side comparison of traditional sensor networks with sensor cloud. So, typically in the traditional sensor networks, we are talking about single user. In sensor cloud, the benefits would be experienced more when we are talking about multiple users. Then in sensor networks, the data are aggregated and sent to the sensor network user, and in sensor cloud the infrastructure basically takes care of it. The sensor cloud infrastructure basically is tasked to aggregate and send it forward. And at the device level, these devices are dedicated to a single user in sensor networks, and this can be improved by serving multiple applications by the different sensors. So, these are the different advantages of sensor cloud over sensor networks. Now, in sensor cloud, we are talking about not a single user or a single actor or a single role, but we are talking about different types of roles, different types of actors. We are talking about sensor owners who basically own the sensor. We are talking about SCSP, sensor cloud service provider, who may not be the owner, but is separate from the owner and is simply the service provider, sensor cloud service provider, the sensing service provider. And then we have this maintenance. With respect to maintenance, again the service provider does it, overhead and usage. And so, we see that we have diverse types of sensor cloud, we have diverse types of sensor cloud actors, and in the traditional sensor network we used to have only a single type of actor, which is the WSN user. So, we have end users, we have sensor owner and the sensor cloud service provider, three different types of actors. We additionally have end users and SCSP, which is basically the sensor cloud service provider, which primarily takes the managerial role. So, we see in this particular figure we have a set of sensor owners, then we have through virtualization, pricing, caching, composition management, we take care of servicing the requests from the SCSP and also sending the responses back, and finally the vertical communication over here with the web portal. So, the left hand side figure basically shows that how the sensor cloud data is accessed through a browser interface. So, we have a browser interface and the template as well as the sensed data are sent to the user organization, and these data from the user organization are basically fed as data feeds to diverse applications. On the other hand, on the right hand side figure, we see the real view of sensor cloud. So, here we see that there are only a few functionalities: scaling, dynamic scaling, then on demand physical sensor scheduling, energy management, quality of service, and application specific real time data aggregation. So, here is the flow diagram, the sequence diagram of sensor cloud. So, as we can see over here, the different actors or roles include user organization, sensor ML interpreter, virtual sensor manager, virtual sensor controller, and resource manager. So, initially from the user organization, a operations request is sent to the sensor ML interpreter. This creates the virtual instance of the sensor, then this is basically sent to manage the controller, to basically function on the controller. A response is received from the controller, the response is again transmitted forward further, and then this XML template is decoded. Like this continues, the data are stored in the sensor resource pool, and different functionalities such as service sensor, physical sensor definition, virtual sensor, group definition, client information, metadata, and templates are used over here in this architecture. Let us now briefly consider a case study. So, we consider a sensor network based target tracking application in which a sensor network owner refuses to share the sensed information with an external body even in exchange of money. Consequently, any organization that wishes to detect the intrusion within a particular zone has to deploy its own sensor network. This leads to the long term investment due to costly network setup and maintenance overheads. However, in a sensor cloud environment, the same organization can use the same tracking application and still get the service without actually owning the sensor. So, this is the whole advantage. You do not, the users have sensing needs, but they do not have to really own the sensors in order to get access to the sensed information about the physical environment of operation. So, with this we come to an end of the first part of the lecture on sensor cloud. The next lecture is going to be on the more advanced topics of sensor cloud, and that we are so there we are going to learn about the different solutions as well, about how to handle different solutions in sensor cloud. Thank you.